I'm now going to give you your assignment for the coming week. I'm sorry that this wasn't included in the previous video, but I ran out of space on the camera card, so it'll be 2 videos this week. What I want you to do for the assignment is, as a team, make the fundamental decisions about how you're going to build your prototype. So you already know what the prototype's going to be, so what it's going to do, more or less, and what kind of person, customer, market it's going to be for. Now, I want you to decide upon these fundamentals, fill in the details, and do this carefully according to most of the suggestions on the optimization sheet that I've uploaded. But as I said in the previous video, it's very important to remain open-minded, retain your creativity at this stage, because it's very easy now to say, okay, that's the end of the imaginative part of the project. Now it's just fairly dull, straightforward work. If that's the route you take, you'll find that the rest of the project's not very interesting, and that you probably end up with a fairly grey, unremarkable, average product that is maybe a bit more complex than it needs to be and a bit more expensive than it needs to be, and doesn't perform as well as it could. But if you remain creative, and even for the smaller parts of the design, you consider several options. So if you're looking at materials, you could be saying, well, for the chassis of the machine, let's look at 3 different materials. Let's think about building a chassis out of metal, let's think about building a chassis out of fiberglass, and think about building a chassis out of wood. You could compare them, you could look at what's available in the developing country where you want to employ your prototype, and you might find, for example, that there's lots of bamboo, and you could very well build a chassis out of bamboo, and that might be cheaper than building a chassis out of metal in your particular country. And the person, hopefully this week, who is assembling your ideas from the different market assignments and putting those together, can hopefully make some specific recommendations for what materials are available in this country, and what kind of lifestyle the people live, how much money they have available, that kind of thing. So that would be one of my suggestions for each of the main components. Compare 3 different materials, the data book which I will upload, and if you want to look at the books by Michael Ashby, you might also find these helpful when it comes to material selection. But before you do that, I'd recommend that you decide on what the features are going to be and what the main components are going to be. Now, you'll start out with a function. Maybe you need a mechanism to lift something. Or maybe you need a control system to maintain a more or less constant speed. Or maybe you need an electronic circuit that can sense light intensity or count something. And I would suggest with any one of these functional definitions of what you need, it's useful for you to come up with at least 3 different ways of achieving that goal, of providing this function, and then compare them. You can do this fairly informally if you want to, and arrive at a decision. So one thing you might want to look at, if you're skeptical at this stage, that there's still much creativity left in the design process, is nutcrackers. If you maybe go to a department store where you can buy a nutcracker, or you have a look on the internet, you'll see that there are maybe 2 dozen, 3 dozen common types of nutcracker. There are ones that are like pliers, where you put the nut into the pliers and then you squeeze it to crack open the shell, and the levers give you a mechanical advantage. There are others that make use of the energy of a flying ball bearing, so to speak. They have a spring, and the axis of the spring is vertical. You put the nut underneath it, you stretch the spring upwards so that the ball bearing is at the top, and then you release it. The ball bearing then strikes the shell of the nut and cracks it open. And you get others where they're shaped like a cone. You push the nut in the top, and then there's a small cam built into the wall of the cone. And when you squeeze the lever, then the cam narrows the cone and cracks open the shell of the nut. And these are all some good examples of creativity at a later stage in the design process. And you'll also find at this stage that you need to make some estimates, you need to guess some things, and this is normal, that you may not have all of the information, and do some thinking, have some discussions, guess. And try to do this in a systematic way. If you do that, you'll nearly always find that you can come up with a guess that is better than an order of magnitude. If you want a little bit more information about this, if you look up Enrico Fermi's "How many piano tuners are there in Chicago?" question. It's another famous example of estimation. So your assignment for this week, I want you to put together a single document which you'll upload to StudIP as a PDF. And in this document, I want to see the results of your fundamental design decisions about how your prototype will be built. If you like, you can also include a better description, an edited description of what market the product is focused on. That will be a strong suggestion from me that you do that. Within this assignment, you can distribute the tasks as you wish in your team. But what I definitely like to see in there is a description of the shape and size of the prototype. So roughly what it's going to look like, how big it's going to be. I'd like to see a list of features, so the main features. I'd like to see a list of the main components. And so once you've compared your different mechanisms, maybe your different electrical circuits and things, figure out what the most important components are going to be, and then list them. You don't necessarily have to list things like all the individual screws or the glue that you need, the seals you need, unless you think that these things are going to be problematic. I then want you to list the main materials that you're going to use, so the materials that you'll be using for the main components. And I want you to list the sources of all the main materials and components. That means, well, maybe your chassis is going to be made out of bamboo. Maybe this is going to be brand new bamboo. Or maybe you're going to take a fan, and this fan is going to be from a scrap car. It's going to have a 12-volt DC motor, that kind of thing. So I want a source that tells me exactly where I could get this material or this component from in a developing country, whether it's new or used, and whether it needs to be substantially modified, like cut to size or machined or welded, that kind of thing. I've got your documents here from the last assignment, so the concept selection assignment, and within this document that you'll be doing for the detailed design and optimization assignment, I'd like one person to take the time to develop a special topic, a special focus within the design of your prototype, and I'm going to recommend what these special topics should be. And the reason I'm doing this is because I like the ideas, but I can see a few places where I'm thinking this could be problematic. And the places where I think it could be problematic, I'm going to advise one person to spend a bit of extra time for this assignment, looking into it, doing some experimentation, so that you understand what you're trying to build better, and you can foresee what problems might arise when you come to actually building the prototype. So for team one, the elephant feces paper, I want one person to try this out. You may not be able to get any elephant dung. If you can't, I recommend that you get some horse dung and try it with some horse dung. Try it with some simple hand tools. So maybe get a bowl, a sieve, maybe a bottle to compress and knead the horse dung, and maybe something to stir it with, a large spoon or something. See how easy it is to shape it into the kind of paper that you want. Maybe you find you have to grind the fibers and it's smaller. Maybe you have to get rid of some lumps in it using a pestle and mortar, that kind of thing. Maybe you want to try some chemicals to bleach it, to try and lighten the color. But at the end of the day, I'd like the person who does this experiment, or if you wish, sounds like a fun experiment, you can do it as a complete team. At the end of this experiment, I'd like them to actually come out with a sample of handmade paper made from dung, just to check at this stage that the concept is feasible. And this is then something that you'll be able to look at and you'll be able to say, well, how can we learn from it? How good was the result? Team number 2, the air conditioner. I would very much like to see a thermodynamic simulation of some kind here. Mainly so that you can get an idea of how important the thicknesses of material and the conductivities of the material are. You may find in this kind of thing that the design is very sensitive to certain thicknesses and conductivities. Maybe it needs certain parts to be highly insulating thermally. Maybe other parts need to be highly conductive. Maybe it's not the parts that you expect. And I want to know how sensitive and how critical these parts are so that you can later say, okay, the most important part is perhaps that this pot has thick walls. Or the most important part is that the pipe that carries the water has thin walls, or that it's made out of a material with a very high thermal conductivity, that kind of thing. So it's up to you what level of complexity you want to do this simulation at. If you're good at mathematics, it doesn't even necessarily have to be a computer simulation, but I want someone who's good at thermodynamics to approach this and maybe come up with a figure for the kind of expected temperature drop that you could achieve using this air conditioner in your country of choice, with its ambient temperature presumably in the hottest months there. Team number 3, the stove. I'd like you to think carefully about the sources of your components. There are a few things which make me a little concerned here. The Peltier element. I'm skeptical that you'll be able to get a Peltier element in a developing country. I think this could be quite a difficult thing to get. I think here in Germany, when we've had some teams use them in the past, they've only been able to get these Peltier elements by mail order. And mail order is something that's not very well developed in other less highly developed countries than Europe or America. You'll find some places don't have street addresses, not everyone has the internet. A Peltier element could be something that's very difficult to get. The filter bags here. I'm not sure if you're intending that the user of the stove will then make these filter bags out of paper or fabric, or maybe get them from a vacuum cleaner, that kind of thing. I'm not sure. I'm also not sure how important the particle collector will be to the user. Maybe it will be quite important if the user of the product lives in a highly polluted developing country like Mongolia, maybe much less so in a country in Africa where maybe they don't see much of the pollution, it doesn't bother them much, and they want to save the money. The PC fan, I think with the PC fan, it might be good to compare this to, say, a fan from a car engine, a car radiator fan with a 12-volt DC motor, or maybe a fan from a broken air conditioner that the richer people that would have in a developing city. Because getting 20 PC fans perhaps to create a really good draft through a stove could be quite difficult. So with this one, I would say think quite carefully about the sources of your components. What can you realistically get in a developing country? And do this in quite a detailed way. Make sure that it's feasible. A couple of pieces of advice for everyone. I've noticed that there are some things in some of your designs that look to me to be either unobtainable in a developing country. I think the Peltier element might be one of these. Or things that are very expensive and not that widespread. I mean, if you need a laptop to connect to your prototype, for example, you can't rely on everyone having a laptop. You can get a laptop in a developing country, but it's something quite expensive. And there are other things which are quite undesirable, like needing a reliable and fast internet connection. If you have a prototype that requires that, you'll find that the internet in developing countries is slower and less reliable than it is here by a long way. And it's also very patchy. So there's some areas where there's good internet and there's some areas where there's very poor internet. Also something to think about in your designs. I'd like this assignment completed and uploaded to StudIP by the 3rd of July. If you've got any questions, please let me know. Remember to keep thinking in a creative way, keep comparing many different options. I've had an email to say that one of your teams has lost a member, Anne-Katrine, who's apparently having an operation. I hope this isn't causing you any problems. If you're finding that you're stuck, that you're having difficulties, that you're not managing to get it done, you're really struggling, please contact me. Please let me know. That's all for today. I look forward to receiving your assignments on the 3rd of July. Thank you.